Today we are going to understand and perform compositions of transformations. In the previous video, we reviewed the 4 different types of transformations we've learned and their properties, what happens to the shapes, and if the shapes are similar or congruent. So in this video, we'll actually compose some transformations. Here's an example of a rule where you have to identify if the transformation was rigid or non-rigid. Remember that a rigid transformation results in congruent shapes, and a non-rigid transformation doesn't. It changes the size of the shape. So we're looking at this, and it has negative 2x and y plus 1 as our image. Because it has the negative 2, we know that it's changing the size of the shape. So because it's changing the size of the shape, it is non-rigid. So basically, if it has any multiplication of a number other than 1 or negative 1 at all, then it is a non-rigid transformation. Now we need to identify if it's similar or non-similar. I'm going to just kind of sketch this out to think it through. So let's say you have a triangle, and what this says is that we moved that triangle up 1 and we flipped it. This is flipping over the y-axis, right? And this is making all the x coordinates be bigger. So it's going to be something like this. Because the negative 2 is to only one coordinate, not the negative's fine. Because the 2 is to only one coordinate, this is not going to be similar. If it were to both coordinates, then it would be affecting both the x and the y, so it would be a similar shape. Now we're going to perform some transformations in order. A composition of transformations occurs when we perform 2 or more transformations in a specified order. And so sometimes you're going to actually perform those transformations, and sometimes you're just going to identify, well, first you did a translation, then you did a reflection, etc. We're going to do example 3. And I'm actually going to change this a little bit. Rather than having only 2 points, we're going to add in a 3. We're going to make a third. We're going to make a triangle. And we still have C and D, but we're also going to have point E. It's 0, 4. So we're going to graph the pre-image, and then we're going to graph the image after each transformation that it says we should do. And it says we should do a translation and a reflection. So just keep in mind, and if you're trying to do this on your own, I would recommend reviewing what translations and reflections are and how to do them, because that is very helpful. Let's go ahead and graph our pre-image. I suppose I should actually see the points. Okay, there we go. So C is at 0, 1. And D is at 3, 4. So 3 on the X and 1, 2, 3, 4 on the Y. And E is at 0, 4. Now I'm going to connect the points into a triangle. I haven't actually done any transformations yet. This is the pre-image. Now I'm going to do the first transformation. It's a translation. And what happens to the coordinates is that X stays the same and Y gets 2 bigger. So that Y getting 2 bigger means that it goes 2 up. And you can review translation rules if you're having a hard time on the previous page or in a previous video. Okay, so I'm just going to take each point and I'm going to move it 2 up from where it is. I'm going to change colors so that this is a little easier to see. So we're going to put E prime right there. And then D prime moves 2 up. And C prime moves 2 up. So this is my new triangle. And it overlaps, that's totally okay, but you do need to remember, like, you might want to, like, erase some lines or make the first one a little fainter if they overlap, just so it's easier for yourself, or color code like I do. Okay, so we did our first transformation, check. To do a composition, we're now going to take the purple triangle, the new triangle, and we're going to perform a reflection with it. So you don't take the original, you take the new one and you make a new one. So it is a reflection across y equals x. Now y equals x is in y equals mx plus b form. So it could be written as 1x plus 0. So then our m is 1 and our b is 0. So b is the y-intercept. So I know from this equation that this line will go through the origin. Remember, we're drawing our line of reflection. This isn't an actual shape after a transformation. We just need to draw this line of reflection before we can draw the reflected shape. So it goes through 0, 0. The m, remember, is the change in y over change in x, or rise over run. And you say, but 1 is not a fraction. Well, let's make it look like a fraction. 1 as a fraction is like 1 over 1. And you can get 1 by having any number over itself. It could be 2 over 2, it could be 3 over 3, etc. So this 1 over 1 means that we move 1 up and 1 to the right, because that's the positive direction on the x. I'm going to do 2 over 2 and 3 over 3. And look, they're all on the same line. I like to use sometimes bigger numbers in my fraction. I create an equivalent fraction because that way it makes it a little easier for me to do the line. So that's our line of reflection. Now we're going to reflect the shape over that line, and it may help you to remember which shape you're looking at. We're going to reflect the image, the second shape, this purple one. So y equals x and any other diagonal line, those are the hardest ones to reflect over. I'm going to show you, it's actually easiest to do coordinates for this one, but if you don't remember the coordinate rule, here's how you do it. You need to have the image of the point be the same distance from this one. I'm going to change to green. And it needs to be the same distance in the opposite direction, and here's the key. If it's a diagonal line, then the lines you draw to the line of reflection should also be diagonal. And what's more, they need to be at a perpendicular. They need to be at a right angle. Now, since we're only going to do y equals x and y equals negative x, just draw the easiest diagonal, go through the dots. So we're going to go the same distance. This goes through 1 square and a half. So 1 square and a half are c. Wait a minute, we have a c prime. So the way you do this is you do c and then 2 little apostrophes, c double prime. That means the image of the image. So there's c double prime, and I'm going to draw my d double prime. It goes through 1 square and a half, so d double prime is going to be right there. And then our e double prime, it goes through 1, 2, 3 squares. So we're going to go through diagonally 1, 2, 3 squares, and there's our e double prime. Now this is a lot of lines, so I'm going to erase these little reflection lines. There we go. And draw my image of the image, my new triangle. And I'm gonna highlight that in, fill it in, just so it's easier to see. Okay, so now we're asked the question, what similarities do you notice between the pre-image and the image? Orientation, size, shape, similar, congruent, or nothing. So the first image that we're going to look at, well, the first shape is the one we're going to compare. So we're going to compare blue and green. Okay, orientation, remember, is not which way the triangle is facing. It is the orientation of the points in relationship to each other. So let's look. E is on C's left in the blue triangle, but in the double image, in the image, E is on C's right. The reason why is because a reflection was performed. So these orientations are not the same. I'm just going to circle the ones that are the same. That'll make it easier. So orientations are not the same. Are they the same size? Hopefully you don't have to verify very much, but if you needed to, you could just look and count one of the sides, and it's 3. They all have the same size. So we're going to circle that the sizes are the same. Are they the same shape? They are both a triangle with side lengths of 3 and then the square root of, I can't do that in my head, the 3 diagonal. Remember Pythagorean theorem? Let's see. Okay, that'd be 9 plus 9 equals 18. So the square root of 18 would be that third side. Okay, so they have the same size and they have the same shape. All the angles are congruent and they are similar, but usually we just choose one or the other. We choose similar or congruent. Because these are the same size and shape, we're going to circle congruent. If they didn't have the same size, but they were the same shape, we'd circle similar. So that's how you perform a composition of transformations. Some things to remember is that you need to take the second shape and perform the second transformation on it. And on all your points, you do need to have labels, and the number of apostrophes you have is the number of times you have transformed the shape. We're going to do an example where we identify what transformations have occurred. So now I don't have to draw as much, and I'm really happy about it. So we're going to go over here, and we're going to do number 8 from my class's homework assignment. Describe the composition of transformations in the correct order. Note the prime, that's 1 apostrophe, and the double prime, 2 apostrophes notation. Okay, so we're going to look at the original shape. It's right here. And then the single primes is the one right above it. So now I have to figure out what happened. You can probably look at it and say, oh, that's a... But just in case you can't, let's look at orientation. So A and C are over there, and then they swap. And then B is all over there the same. So this orientation is different. And the only thing that has the orientation different is a reflection. And to find our line of reflection, it should be the line that is equidistant from the first, the pre-image and the image points. It's that line right there, and that is the x-axis. So I'm going to write reflection over the x-axis. Its other name is y equals 0 because all the y coordinates on that line are 0. Now I'm going to take the purple shape and I'm going to find out how it gets to this one. So our orientation is the same. A and B are both on top, left to right, and then C is on the bottom. It looks basically exactly the same. It's just moved. And so that tells me that this is a translation. And now I need to say how much it moved in each direction. So take 1 point and figure out how much it moved to its corresponding point. It's very tempting to just be like, yeah, it's over there. But you need to find out how much the whole thing moved. So you need to go from 1 point to the point of the same letter. So it goes 2 up and 1, 2, 3, 4, 5, 6 right. And it's very important to remember that you're going from the old shape to the new shape. So keep in mind which one is the primes versus the double primes. Now, unless it tells you, you do not have to write a function rule, but sometimes you might have to identify the function rule. And then I would use the rules that you have listed, or this one's actually really easy. You just say 6 right is x plus 6. And then 2 up is y plus 2, and then put that in your function rule. So if it asks you to write a rule or a function, you're going to do that XY arrow. All right, good luck.